Alrighty. So today we're going to talk more about reputation and about this sort of different kind of reputation from what we talked about last time. And I give a warning that I think that this is the most complicated and confusing lecture of the semester. So I will do my best and hopefully it will make sense. Also, before I start, I just want to make a plug for people that are interested in fake news and stuff like that. I'm giving a talk tomorrow from noon to 1:30 at YINS, the Yale Institute for Network Science, on this totally other set of work related to what makes people believe fake news and what you can do to get them to believe it less, which is something I never thought about before the election, and now I'm doing a ton of research on. So if you're interested, check that out. Okay, so what we talked about last lecture was indirect reciprocity. Remember, the idea of indirect reciprocity is that if you have a good reputation, then I have to cooperate with you now because I think that other people are going to cooperate with me in the future if I do that. That is, I'm required to cooperate with you now in order to maintain my good reputation, which is valuable in the future because others require it from me to cooperate with me. And so it has this coercive logic of reciprocity that is essentially the threat of future partners saying, I won't cooperate with you next time if you don't cooperate with your current partner now, compels me to do the thing that's costly. Like, it's costly for me to cooperate, but I'm willing to do it in order to earn my good reputation. And what we're going to talk about today is the other way that reputation can work, which is what I'm calling signaling. And so here, if you have a good reputation, I'm cooperating with you not because I'm worried about what others are going to think of me in the future or whatever. It's just straight up that I think that if you have a good reputation, you're likely to cooperate with me now. And the structure of the interaction is one such that it's directly payoff maximizing for me to cooperate if I think that you're also going to cooperate. That is to say, for me, the game is a coordination game. So if we're playing a coordination game, and I have reason to expect you to cooperate, then I'm going to cooperate with you. It doesn't matter if other people are watching, it doesn't matter if anybody knows anything, it's just there's directly, it's an equilibrium to cooperate if you think the other person's going to cooperate. So we're going to unpack this, in some detail, but as an illustrative example, to motivate sort of these two different kinds of sort of reputational incentives, imagine two different situations in which you're interacting with someone whose reputation you know. So we're going to do a sort of a traveler versus like a tradesman or a trader. So imagine you're interacting with a traveler, that is somebody just passing through, and so you know that you're probably not going to interact with them again, but if they're in a good reputation, so if they're in a good reputation, you still are sort of required to help them. That is, it's costly to you. You're not going to get anything back from it because they're just going to move on to the next ice cream shop. But you have to cooperate with them in order to maintain your good reputation. And you can contrast this. So here, you have to help them because otherwise you get a bad reputation. This is indirect reciprocity, motivating you further. And so this means that you're only going to help if people are observing you. So if you can get away with not helping the traveler, you would rather not help the traveler because you're not ever going to see them again. So the only reason you're doing it is worrying about what other people think. If other people can't see what you're going to do, great, let's not help. And also, imagine that you have some private information where you know that the traveler is actually a bad guy, but you know that everybody else thinks he's a good guy, then still you'll cooperate with him because the only reason you're cooperating is sort of to look good for other people. So if other people think this guy is nice, then you have to cooperate with him even if you know he's not nice. And vice versa, say that you know that actually he's a great guy and is always being very cooperative, but everybody else, for whatever reason, thinks that he's not a good guy, then you won't cooperate because you don't want to cooperate for any intrinsic reason here. And if the rest of the community thinks that he's bad, then there's no coercive pressure forcing you to waste money on cooperating with him. So this is the sort of like reciprocity logic here. And now we're going to contrast our traveler with a trader. That is, somebody that's offering you something that you want, like a delicious squash. If it turns out, in fact, to be a delicious squash and not like a rotten crappie squash that he just found on the side of the road and didn't have to invest money in making, a good squash or whatever. And so here, particularly if you like squash, it's directly beneficial for you to sort of have a cooperative interaction with this person, as long as you think that you can trust that he is actually going to be cooperative. And so in this situation, the signaling situation, whereas reciprocity means you have to help because otherwise bad things will happen in the future, here you want to cooperate or interact if you think the other guy has a good reputation. And so what this means is it doesn't matter if other people are watching you. You just sort of are directly wanting to cooperate here if you think the other guy's going to cooperate. And what matters is your private information and not the public information. So if you imagine a situation where you know that the guy's reputation is good, even though everybody else thinks his reputation is bad, you'll still want to cooperate with him because you think that he'll cooperate with you. And vice versa, if everybody else thinks he's a great guy, but you privately know he's a jerk, then you won't want to cooperate. And so these are these sort of key differences between the indirect reciprocity version, which is all about observability and other people's opinions, versus signaling, which doesn't matter if you're observed, and what matters is your opinions, your beliefs. So we already talked about this a lot last lecture, and this is what we're going to focus on today. And within this category of signaling, there's two different kinds of signaling that we're going to talk about. In both cases, we're thinking about two-player interactions where player 2 sends a signal to player 1 that reveals some information about player 2, and then player 1 decides whether or not to cooperate based on that signal, and player 2 also makes a cooperation decision, and then they get their payoffs. And one kind of signaling is called costly signaling. And the idea of costly signaling is there are different kinds of player 2s. That is, there are player 2s that have different payoff structures, and they're able to send some signal that reveals their type, such that then player 1 wants to cooperate with the sort of good types and wants to not cooperate with the bad types, and the signal sort of honestly reveals type, and we'll talk about how that works. And then the other one is strategy signaling, where in strategy signaling, all the player 2s are the same type. Everyone has the same set of payoffs, but the player 2 is able to credibly pre-commit to a strategy, and then sends a signal that conveys information about what strategy player 2 has committed to, and then player 1 can respond. Okay, so we're going to start with costly signaling. And costly signaling is this idea that originated in biology, actually, with the peacock as the paradigmatic example. Like peacocks are birds. Peacocks have amazing, crazy tails that are, this beautiful thing that everybody thinks is great, and I look at that. But the thing about it is, a tail, although it is cool to look at, it kind of sucks if you're a peacock with this huge tail, because A, you're wasting a huge amount of energy growing the big tail, and then once you have the tail, you're like real slow, and if somebody wants to try and eat you, you're like much less able to get away than if you didn't have this big tail. And so it was like a big sort of evolutionary puzzle of like, how do we explain the presence of these tails? And this was a cool example of some evolutionary biologist came up with some logic for this, but like nobody really believed him. And then eventually someone came up with a mathematical model that like showed, that sort of proved how it worked. And they were like, oh wow, okay, I guess it was really cool. So it was a place where the math was compelling. But the logic goes like this. Okay, so if you are a peacock and if you are a male, so only the male peacocks make the big tails, and you are interested in attracting female partners, and females in terms of picking which male they want to mate with, they're trying to select the mates that have good genes that lead to sort of high fitness. Having a big crazy tail it's costly for all peacocks to weigh you down, but the higher your fitness is, the faster, stronger, sort of better at life you are as a peacock, the less costly it is going to be to make a big tail. Because if you're good at finding food and stuff like that, you're not calorie strapped, so you can afford to invest the calories in making a big tail. And if you're real fast and smart and whatever else peacocks do, a real sharp beak, something like that, that's a joke. Whatever it is that you're basically good at staying alive, the better you are at staying alive, the more you can afford to have a big tail. And so what that means is that this sets the stage to allow tails to credibly signal fitness, because having the big tail gives you some benefit, the benefit of being more likely to be chosen by the female peacocks, and it comes at some cost, which is the metabolic cost and risk of getting eaten. And the issue, or the idea here, is that because the tails are differentially costly based on type, if you're a high-quality type, or where you will get costly signaling to work is when it is the case that for the high-quality types, the cost of growing the tail is less than the benefit, so that it's worth, growing the tail. Whereas for the low-quality types, the cost is higher, and the cost is greater than the benefit. So it's sort of net worth it if you're a high-quality type, and it's not net worth it if you're a low-quality type. And therefore, the signal stays honest, because only the high-quality types invest in growing the tails. And so this is this key logic of costly signaling. And it's really, costly signaling, costly is nice because it's one word, but really a more accurate thing would be to say differentially costly signaling. That the key here isn't that the signal is costly, but the key is that the cost of the signal differs depending on your type. So if you're a high quality type, the cost is lower, and therefore it's worth sending, whereas if you're a low quality type, the cost is higher, so it's not worth sending. Okay, so that's the logic with birds and tails, but now we want to sort of bring that logic into the domain of cooperation. And so here, the difference in type that you're trying to signal is not your genetic quality, but it's instead, it's whether you're a good partner or not. And what that means is whether you have an incentive to cooperate sometimes, that is, you've experienced the game as like a coordination game, or if you don't ever have any incentive to cooperate, so you experience it as a social dilemma, which means you're definitely going to defect and therefore are not going to be a good partner. And there's lots of reasons that there could be variation in quality of partners in cooperation. It could be that for the high quality partners, it's cheaper to cooperate because they have more skills or strength or resources. It could also be that they have a bigger benefit, like more specialization. It could also be just that the high quality types are more exposed to direct reciprocity or indirect reciprocity. So remember, we learned about how reciprocity transforms a social dilemma into a coordination game. So that's another possibility, is just that the high quality types are more likely to stick around and therefore care more about the future, and therefore it's worth it for them to cooperate, whereas the low quality partners are going to take off, so it's not worth it for them to cooperate. To sort of show this a little bit more formally, we imagine this costly signaling setup where for the first player, we said, remember, the key difference between signaling and reciprocity is that for player one, in signaling, it's a coordination game. So if you think the other guy's going to cooperate, it's payoff maximizing for you to cooperate also. So here is an example of such a payoff, which you might recognize from the problem set. 2, I think, is like a trust game, basically, for player one. So if player 2 cooperates, then player 1 does better by cooperating than defecting. But if player 2 defects, then player 1 does better to defect than to cooperate. So it's coordination. And now, what gets filled in for player 2 depends on player 2's type. So if player 2 is a low quality type, and here by quality we mean sort of your quality as an interaction partner. So these are like partners that player 1 doesn't want and partners that player 1 does want. So if you have a partner that player 1 doesn't want, then for you, it's a social dilemma. So if player 1 cooperates, so if player 1 cooperates, you do better to defect than to cooperate. If player 1 defects, you do better to defect than to cooperate. So again, in the trust game framework, we imagine that player 1 starts with 10 units. If player 1 cooperates, that gets tripled to 3 units. And then if player 2 can either keep the whole 30 units by defecting or split it by cooperating. And unlike the problem set, I just put in a small -1 where imagine that if player 2 defects but player 1 cooperates, player 2 plays some negligible cost, so there's not a neutrality there. Whatever, it doesn't matter that much. The point is, here, there's only one unique equilibrium, which is both people defecting, because player 2 is going to always have an incentive to defect, and therefore player 1 should also defect. In contrast, imagine this high-quality partner where everything's exactly the same, but this partner is exposed to some sort of mechanism that makes it so that mutual cooperation is particularly beneficial. So instead of getting 15, here, if player 2 decides to sort of be trustworthy, player 2 actually directly benefits from it. So here, it's a coordination payoff for player 2. If player 1 is going to cooperate, player 2 would rather cooperate than defect. And so here, that's still an equilibrium, but also mutual cooperation is an equilibrium, and it's the good equilibrium, it's risk dominant, it's the thing that you would expect to happen. And so basically, when if player 1 knew they were playing with a low quality partner, they would defect. If they knew they were playing with a high quality partner, they would cooperate. And so the challenge now is that player 2 wants somehow, particularly if player 2 is a high quality partner, player 2 wants some way to communicate to player 1, hey, I'm a high quality type, I'm going to cooperate, so you should cooperate with me. Ideally the low quality, that is from their perspective, the low quality player 2s would also like to claim they're a high quality to trick player 1 into cooperating, but in order for this whole thing to work, we need to have something that keeps the signal honest. And this is what I was saying, the key to the costly signaling here is differential cost or benefits. So again, to say for player 2, the cost of the signal has to be less than the benefit of player 1 cooperating. That has to be true, but that is, it's sort of worth sending the signal if the benefit is greater than the cost. And it has to be worth sending the signal for the high quality types, but not for the low quality types. And so, again, it's not that the thing that matters isn't that it's costly, but that it's differentially costly depending on whether you're a good or a bad type. So to make this concrete now in the context of the payoffs that we looked at on the previous screen, say we've got these two different possible games. This is the game when it's a high type player 2, and this is the game when it's a low type player 2. Imagine that what player 2 can do is send a signal, and sending the signal means incurring some cost X. And so then imagine that player 1 believes the signal, and by believes the signal, that means player 1 cooperates when player 2 sends the signal, and defects if player 2 doesn't send the signal. Then you can say, what is the benefit of sending the signal? Okay, well, if you're a high type, then when you send the signal, and that means that player 1 cooperates, then you also want to cooperate. So you get 35, whereas if you don't send the signal, you get 0. So it's worth 35 points. That is, the benefit that you get from the signal getting sent is 35 points. Conversely, if you think about the low type, you're going to defect no matter what. And if you don't send the signal, player 1's also going to defect and you get nothing. If you do send the signal, player 1's going to cooperate and you get 30. So the benefit of sending the signal is 35 for the high types and 30 for the low types. And so that means the net cost of sending the signal, that is the benefit minus the cost, is 35 minus x for the high types and only 30 minus x for the low types. Which means that if you have a signal whose cost is between 30 and 35, then its net beneficial to send, it's sort of worth sending that signal for the high types because the benefit they get is greater than the signal. It's not worth sending the signal for low types because the benefit they get is less than the signal. And so if you're in this parameter regime, then the signal is credible. That is to say, only the high types will actually send the signal, and therefore it makes sense that player 1 actually paid attention to the signal, and you can show that this whole thing constitutes a signaling Nash equilibrium where player 2, only high type player 2 send the signal, and player 1 cooperates only if the signal is sent. And so that is an example of how costly signaling can create this cooperative Nash in a situation that otherwise you might not necessarily get any cooperation. Okay, so that's one way that costly signaling can work. Here, we assumed that the cost was the same for both types, and it was the benefit that differed, right? And note that a sort of funny feature of this is it's saying that the signal isn't special. It's just, the point is, if it's worth 35 for me and it's only worth 30 for Anton, then I can show that, I can say, look, I'm willing to burn $32 worth of goodness in order to show you my type. And it doesn't matter that I'm willing to give up, I'm willing to incur a cost of 32 units just to prove that it was worth more than 32 units to me. And it doesn't matter what that is. It could be giving money away to strangers. It could be performing arbitrary rituals that take a lot of time and effort. It could literally be burning money, just to show, look, it's worth it to me to give this up. So that's one possibility. But another possibility is that there are situations where rather than the benefit varying, everyone gets the same benefit, and the thing that varies is the cost. So you can imagine that to work through the logic, now we want to look at the player 1 side also, but to say both players, regardless of whether you're a high type or a low type of player 2, you get a benefit B from being accepted. And then imagine that player 1 gets W from positive payoff from accepting high types, and minus X, so incur some cost from accepting low types, and that's why player 1 wants to differentiate between them. Then if we say that there's two different signaling costs, so that the signal costs Y for the low type and Z for the high type, where Y is greater than Z, right? The whole point is that the signal is more costly for the bad type than for the good type. Then you can have a signaling equilibrium where you can have a signaling equilibrium as long as Z, so the cost for the high type, is less than the benefit of being chosen, which is less than the cost for the bad type. So this is just sort of like the reciprocal of the thing on the previous page. But the thing that's cool about this version of costly signaling is now the signal isn't arbitrary. But in order for something to be a good signal, it has to be a signal where the cost of that signal is correlated with, with your type, such that there's something that makes like low type, makes signals more costly for low types than high types. So, for example, if you could imagine that, one example is like, sorry, let me say that once again, slightly differently. Okay, so in the previous case where the cost was the same for everyone and it was just that the benefits varied, it didn't matter what the signal was, you just had to show that you were willing to pay some cost. Here, in this case where the cost varies, the idea is like you're trying to signal that you are a cooperative type that has a coordination payoff, right? So you're, again, the point of the signal is to say, are you someone that finds mutual cooperation really rewarding, such that you get coordination payoffs? Or are you someone for whom mutual cooperation isn't that rewarding, so you see social dilemma types, and so you're just going to defect no matter what? You being player 2 here. That is, remember, all of this is about player 2 trying to signal, am I a type that finds mutual cooperation beneficial or not? And so here, in order for this whole thing to work, it has to be the case that the signal, the thing that, like, the signals are less costly for people that find cooperation more beneficial. So, it could be something that then you would want to say, I engage in other cooperative behaviors as a way to signal that I find cooperation beneficial, and you'll trust me in this cooperative situation. And it has to, I couldn't just burn money, because burning money is equally costly regardless of whether you're a cooperator or not. You have to be sending a signal that is specifically related to cooperation somehow. And so this can also then help explain certain types of cooperative behaviors that seem like they're not at all beneficial. So like contributing to big public goods that benefit everyone in the world, but you don't really get any kickback from. Or say you see someone that you don't know do a bad thing to somebody else that you don't know, and if you might sort of punish the wrongdoer to try and sort of teach them to behave better in the future, that looks like you're just throwing money away, but given that that is a sort of form of a pro-social act, it turns out we'd show that that's another reason you might engage in this third-party punishment, is a way to signal that you are a cooperative type, so other people are willing to trust you. Okay, so that is that's all that I'm going to say about costly signaling. It's sort of a complicated idea, but I feel like, at least in my experience, it was once you wrap your head around it, it's really cool because it gives you a lens for seeing all different kinds of social behaviors where people are doing stuff that seems costly and weird, but if you realize it's differentially costly for different types, then there's signaling value. So you can think about things like wearing fancy watches for men is a way to signal that you're rich, basically, because if you are rich, you can afford it. It doesn't matter that much. If you're not, then it's much more you have to spend your whole month wages on it, whatever. It's not worth, even though everyone would get the same benefit from showing it, it's not worth incurring that cost.
So it can be differential in relative terms. That would be sufficient. Yeah,
right. That is, it's right. Yeah. The ultimate version of that was some Facebook app that I in sort of the early days of the an iPhone app in the early days of the iPhone that Apple discontinued because they thought it was bad PR. That someone had the idea of making an app that was called I'm Rich, and it cost like $1,000 and didn't do anything other than you could show it on your phone that you have the I'm Rich app. Okay, so that's costly signaling. What happened? Weird. Okay, so now let's talk about strategy signaling. So in strategy signaling, it's not the situation where there's different types. It's just all of the player twos. That is, this is a payoff matrix for everyone, where for player one it's a coordination game, and for player two it's a social dilemma, and so the unique equilibrium is both dual defecting. But now imagine what could happen if, instead of having to simultaneously choose their actions, if player two could credibly commit to a choice between either C or D, and then communicate that commitment to player one, such that player one could condition his choice on player two's choice. So now, instead of being a simultaneous game, it's something that happens in stages, so we'll sort of use it with this game tree, as they call it. So they say that player two commits to either cooperate or defect, and then player one finds that out and can either cooperate or defect. So if player two cooperates and player one cooperates, you wind up down here. Player two defects, and then player one cooperates, you wind up down here. And so now we can fill in, these sort of four possible outcomes of this tree are the four possible cells here, right? So if player two cooperates and then player one cooperates, they both get 15. If player two cooperates and then player one defects, they wind up in that cell and get player one gets 10 and player two gets -1, and so on. And now that you're in this tree, we can say, well, what will player one do? So if you get to this node such that player two cooperates, and so now player one is faced with a choice between these two options, player one prefers cooperating over defecting. Whereas if player 2 defects and then player 1 winds up in this node, player 1 prefers defecting over cooperating. That is, for player 1, it's coordination, right? But what that means is that now when player 2 is making a decision, player 2 is choosing between C and D, but now sort of knows what player 1 is going to do as a result. And so so what that means is that player 2 knows that if they cooperate and signal that, player 1 will cooperate and they'll get 15. Whereas if player 2 defects and that gets signals, player 1 will defect, which means player 2 will get 0. And so this sort of choice now for player 2 is such that player 2 will prefer cooperating over defecting. And that means that in this sort of extensive form game, as they say, this game that has this back and forth, this sort of non-simultaneous nature, it actually becomes mutual cooperation is the only match. And so by flipping around this the order of things and making player 2 go first, move it from DD to CC, and therefore that also means that we increase player 2's expected payoff from 0 to 15, which means that player 2 should be willing to spend money to send a signal because player 2 is benefiting by getting out of the DD equilibrium. And now in this case, we're not talking about spending money in a buying an I'm Rich app kind of thing, but rather we're talking about having some elements of your strategy that are otherwise costly, but that allow you to credibly commit to a strategy. So, for example, you could sign a contract. This is how things work a lot in the world, where you hire a lawyer, you incur some cost to draw up a contract that's legally binding. It says, if you, player 1, do this, I, player 2, will respond accordingly, and therefore that's an enforceable pre-commitment to a strategy. Player 1 knows that you're going to cooperate, and therefore is willing to cooperate also. Also, you don't need it to be a legal contract. It could be enough to make a public statement of, I am planning on cooperating, such that everybody else sees it, and if I don't cooperate, then there are indirect reciprocity costs or costly signaling costs to me not doing it. Okay, another possibility that has been suggested by Robert Frank, this economist at Cornell, is that part of what the role of emotions are sort of hard to fake signals of your strategy, such that if you really are in love with someone and demonstrate the emotion of love, then that seems like a credible commitment that if I see that you really love me, then I can trust that you're not going to take advantage of me. And similarly, anger can be a credible emotion of a threat of don't mess with me. So that's another option. A third option is to say, basically, I tie my hands such that I promise, not promise, but this has to be some actually enforceable thing, but you adopt a strategy that says, I don't learn, essentially. And so my behavior won't change. So if you saw that I cooperated in the past with someone else, that means I'm almost certain to also cooperate with you this time. And then a final one is that in an observable way, you can decline information that would be necessary to figure out whether it's good to defect or not. So if you say, I don't even want to know what the costs and benefits are, such that I couldn't possibly figure out whether I should take advantage of you or not, that's a credible way of committing to not knowing even that it would be a good idea to take advantage of you. And so what all of these different things have in common is that they're costly in the sense that if there wasn't some signaling thing going on, it would be bad to do all of this stuff. So, making the contract is directly costly. Having observable emotions is good for signaling, but in general is bad because it means people can predict you and take advantage of you. And in general, sort of like, being able, like allowing people to read you is not strategically optimal unless you're trying to signal something. Same thing, not learning or learning slowly is in general bad because learning is good, allowing you to adapt to changing environments and so on, but it can have this signaling advantage. And declining information is obviously a bad idea because it leads you to make decisions that you wouldn't make if you had the information, so that it sort of makes your decision making worse, but you exchange that for the ability to signal that you are going to be trustworthy. And so what I'm going to do now is I'm going to just give you an actual sort of numerical example of this declining of information version of strategy signaling. And this is this cool paper that came up a few classes ago called Cooperate Without Looking. And so in this paper, they model a repeated interaction between player 1 and player 2. They call it the envelope game for reasons that will become apparent in a minute. And so the structure of the game is that, so first, player 1 has the choice to either cooperate, which means they both get 3, or defect, which means player 1 gets some temptation payoff, and player 2 gets -10. And then player 2 gets to decide, do I want to continue this relationship and keep playing again, or do I want the game to end, in which case neither of us gets any more payoff. And so the issue here is if you just sort of think about it here, we have to say that player 1 gets some, okay, fine. So player 1, T is always positive. And so every time that player 1 plays the game, he benefits from playing because he's either going to get 3 or going to get T. So he wants player 2 to continue the game. Every time that player 2 continues the game, player 1 is guaranteed to get more money in, so likes it. But for player 2, if player 1 defects, then player 2 is worse off than if the game hadn't happened. And so from player 2's perspective, player 2 only wants to continue the game if player 1 is going to cooperate. And then if T was just some fixed value, we could calculate, what is the equilibrium, and it could either be an equilibrium for player 1 to cooperate and player 2 to continue, or player 1 to defect and player 2 to end. But the key idea in this cooperate without looking setup is that each time they play the game, that is each round through, this cost varies. And you could imagine, just for simplicity, we'll say there's 2 possible values. Sometimes the temptation is low, and so the temptation is only 1, such that player 1 would prefer to cooperate over the defect. And sometimes the temptation is high, say 5, such that when it's 5, player 1 would prefer to defect than to cooperate. And so the key innovation in this model is they say it's not just that player 1 chooses whether to cooperate or defect, but also before making that decision, player 1 chooses whether to open up the envelope and find out the cost. Sorry, I guess I should say the envelope part. This is just not literally an envelope, it's a metaphor. But the idea is there's some temptation that's high or low, and it gets sealed in an envelope. So player 1 doesn't know what that what that temptation is. And so then the first thing that player 1 decides is, do I open the envelope and find out the temptation, or just not even look at the envelope and not know what the temptation is? Then I go on to decide, do I cooperate or defect? And then player 2 says, do I want to continue the relationship or not? And so if player 1 defects, then it's no ambiguity. Player 2 is like, okay, I don't want to continue this relationship. But imagine the case that what happens where player 1 opens the envelope, looks at finds out the temptation, and then decides to cooperate. What should player 2 do? Well, player 2 can pretty reliably assume that when player 1 looked, he got the low temptation. Otherwise, he would have defected. And so the fact that you looked in the envelope and then you cooperated suggests that even though this time worked out well, if sometime in the future you were to open the envelope and find out it was the high temptation, then you would defect on it. And so if so that we can derive the condition under which player 2 says it's not worth it to me to continue this relationship if there's some chance, basically, if you're going to throw me under the bus when you get the high temptation. And so you can say, okay, if player 2 it just ends, so player 2 is now seen, and player 1 looked, and player 1 cooperated, and now player 2 has to decide, am I going to end or continue? If player 2 ends, then in the future, like in the next round, the payoff is just 0. And if player 2 continues, then so if we say that the low temptation happens with probability t, and in that case, player 1 is going to cooperate. In that case, player 1 is going to cooperate. So the expected payoff from that is 3 times p. But with probability 1 minus p, it's going to be the high temptation. Player 1 is going to look and realize that, and then player 1 is going to defect, which means player 2 is going to get minus 10. So that means with probability p, player 2 gets 3. With probability 1 minus p, player 2 loses 10. So if this thing is less than 0, that means the expected value of continuing is negative. And so basically saying there's a high enough chance that player 2 is going to wind up with, there's a high enough chance that player 1 is going to wind up with the big temptation and screw over player 2, that it's not worth it for player 2 to continue, even though this time player 1 was nice and cooperated. And so if this condition is met, then when player 1 looks, even if player 1 cooperates, player 2 won't continue. So let's consider what happens in the case where player 1 decides not to look. Sorry, yeah?
Does looking at the envelope happen before the first game or after the first round?
So every round is of this format, where first a temptation gets sampled and put in the envelope, then player 1 decides, do I want to look in the envelope or not? Then player 1 decides, do I want to cooperate or not? And then player 2 decides, should we do it all again?
Infinite amount of rounds as long as player 2 continues?
Yeah, so in the simplest form, you can assume that. We could also add a continuation probability, and then we're just going to discount this by the continuation probability. And so the idea of not looking is that if player 1 doesn't look, then player 1 doesn't know which specific temptation is in the envelope. And so player 1 has to assume that it's just the average value. And so if you think, what's the average value what's the average temptation? Well, it's p times 1 plus 1 minus p times 5, right? Because with probability p is 1, and probably 1 minus p is 5. And so if player 1 is then deciding, should I cooperate or not, they're making a choice between do I want to get the payoff of 3, or do I want to get the expected payoff of p times 1 plus 5 times 1 minus p. And I guess the w, I forgot here that I guess I did include, let's say there's a continuation probability w. And so at this time that player 1 is trying to decide what to do, he knows that well, yeah, sorry, I think let's ignore. No, I guess it does matter, right? Because you're deciding whatever. I think this is a little bit messed up. But the logic, the logic is that at this juncture, player 1, rather than comparing the cooperate and things keep going payoff to the defect temptation, rather than looking at the actual temptation that's in the envelope, player 1 is looking at the average temptation. And so what that means is if on average the temptation is low, then it's worth it for player 1 to say, I'm just not going to look in the envelope and I'm going to cooperate because probably the temptation isn't going to be big, and by not looking, I commit myself to cooperating, and therefore player 2 can trust me in future rounds and be willing to continue the relationship. So this is sort of supposed to be a model of things like you might get upset if, say, you're in a relationship with someone and you're sitting in a restaurant and they're just like checking out every person that walks by, and after each person being like, okay, no, you're cool. Like, I'd rather be with you. I'd rather be with you. I'd rather be with you. Like, that's not that cool, right? And this argues that the logic for that is that getting left by your partner really sucks a lot, and so you're not willing to be in a relationship with someone that's constantly saying, is there something better, in which case I'll leave you. And instead you want someone that will pre-commit to saying, I'm just not even going to consider other people, I'm so in love with you, etc. And then this could also potentially provide some evolutionary logic for why you have love in the first place, as a way to credibly commit that you're not checking out other people. Okay, so to summarize, in signaling, in all the different signaling stuff we talked about, there's this asymmetry where player 1 experiences the game as a coordination game, and player 2 either definitely doesn't that it definitely has a social dilemma in the strategy case, or may or may not in the costly signaling case, but the key is that they have some way to credibly signal that cooperativeness. And so in the costly signaling case, where some player 2s have coordination payoffs while others have social dilemmas, you can get a signaling equilibrium as long as the cost of signaling is smaller relative to the benefit for the sort of good player 2 partners that have coordination payoffs relative to the social dilemmas ones, such that it's only worth sending the signal if you're a good type player 2. And in strategy signaling, everyone sees it as a social dilemma, but they have some way to bind their actions, which creates an incentive for player 2s to observably commit to cooperating, to therefore induce player 1 to cooperate. Okay, so that's the end of things involving repetition and reputation, and now we're going to switch to mechanisms that can incentivize unconditional cooperation, starting with kin selection next time.